Hello, everyone. I'm going to start with a show of hands. Who here is working on a project that has 500,000 lines of code or more? 1 million lines of code or more? What, 2 million? 4 million? Are you kidding? 8 million? Okay, wow, okay. Wow. Who is working on a project that lasts 5 years or more? Okay, that's everyone. 10 years or more? 20 years? 30 years? Really? 40? 50? Okay, so that's kind of the problems that we have, that our customers have, rather. A trick question now. Is anyone working on a project that is normal, that doesn't have any quirks? Okay. So that's what we get. I mean, when we deal with projects that are 5 years or more, that have 1 million lines of code or more, there's always quirks. There's always, we're transitioning from this very specific exotic platform. We have inherited this very fancy, very strange build procedure. We have these workflows that are complex because we have a big team, a version control system that's very dominant. We have a lot of procedures to ensure the safety of our processes, make sure the code is reviewed, et cetera, et cetera. This presentation is about how we can address these issues, a number of things that we have done, maybe things that we can help in the future to solve that kind of issues. When we talk about workflows, there's really three things. Workflows defined by procedures. You should do this step in step. Or constraints defined by procedure, meaning some companies decide to enforce completely the development environment, decide we're going to have a team that's going to develop the development environment and provide it to the rest of the team. Or can be completely free, left to the developer, the engineer, to figure out which tools they want to use for doing the job. There's a wide variety amongst our customers, and this is not linked to size of projects. This is really cultural differences, cultural choices. And there's no right or wrong choice. Each has their advantages, their inconvenience. We're trying to accommodate a multiple of them, if not all of them. There's workflows defined by version control system. This would be a standard Git workflow. You're asked to do this step from the VCS, and then you can do your code and test, and you're asked to do this for sending your code to review. So this another generally quite strong component of what defines the workflows that you have to work with. And lastly, defined by the environment. Where is the machine that people are working on? Where is the machine where the code lives? Where is it built? What is involved in testing it, running it, working with it? All of these are constraints. And I'm going to talk a bit about, so this is typical workflow in the GPS team at AdaCore. GPS is 440,000 significant lines of code, so it's a small project. Generally, people work on their workstations of their choice. They can use Mac, Windows, or Linux, and they can do the whole development cycle on their workstation. So it's very comfortable in a way. They have the choice to use interactive servers. We have 2 machine rooms where there's very beefy, very powerful servers where people can develop, if they choose to, that are faster to compile, faster to test than a typical workstation. So this is what I'm familiar with personally, and this is what, of course, as a consequence, I consider the ideal workflow, that I would encourage people to try to aim to that. And of course, it's never possible out of the box to do that. Here's an AdaCore customer that shall remain unnamed. What they do is they have developers working at workstations where they only the only thing that's running on the workstation is remote desktop software, and they access a shared server where everything happens. They launch the IDE on the shared server, build and debug there, do the version control there, and this can be very uncomfortable for them because of network issues or because the shared server is powerful but shared amongst many people who are competing for processor usage or disk usage. But I will say this is a rather classic setup for our customers. A lot of people recognize that. And there can be wide differences here. Some people have this shared server next door or in the basement. And some people have this shared server in another state, which, of course, makes development completely different. Lastly, so that's another, at the other end of the spectrum, another AdaCore customer who I'm insanely jealous of them because they have a build farm where they have 200 cores available to build their 4 million lines of code project. And they actually came to us and said, help us with the GPR build distributed so that we can take advantage of this farm. And they did, they reduced the compile time, the build time from hours to minutes. And of course, I would like to ask my CFO over there if we could have a 200 core build farm, but the answer is going to be no. No? Yeah, it's no. It's no. Okay. Too bad, because, okay. The reason I'm mentioning them, not because I'm jealous of them, is because that's a case where customers came to us with a problem, and we helped them with a solution, and I think that's a good illustration of the fact that I would like to encourage our customers to ask us about setup, work environment question, comfort level questions, not just, how do I compile this, or like, how do you do this in Ada, but like, how can I organize my tools to make the life better for the engineers? And I think, personally, I think that's very important. That's a factor that should not be considered, overlooked. The comfort of people working on the project. All right, so this is the kind of problems we've had from the start. We have some guiding principles, not only in GPS, but in GNAT Pro. GPS should never get in the way of workflows. In fact, GPS is optional for our customers. We have a lot of customers who are very happy using other tools. Fine. GPS should be flexible to adapt to any workflow. That's a big statement to make, and we're really trying to make it so. Like, we had a user who wanted to use GPS as a lightweight editor. Just launch GPS, edit one file, close GPS, launch GPS, edit another file, close GPS. And we worked hard to make this something that's possible, for instance. Most of the features in GNAT Pro are available from the command line. We never use any proprietary format for storing information, for instance, the GPS preferences, navigation database. This is all an open format. You can use that to tailor it, to make it useful for your workflow. On top of this, we had a breakthrough in GPS about 10 years ago, I think, when we introduced Python customizability. You can now use Python to script GPS, and that's proven very valuable for some of our customers who made the leap and who developed their own scripts to tailor the environment to their workflow. Now I'm going to share what I think are 3 common questions and 3 things that are of help to, I think, a lot of people. And of course, this is the tricky part of this presentation, like how to tailor GPS to all of your workflows, there isn't a secret sauce that will work on all of the workflows. A question we get a lot is using GPS remotely. We have an option in GPS to say, OK, there's a GPS remote mode where GPS will take care of grabbing the files from a remote server. You edit them in place. GPS will send the files to the server and compile them over the server. So we have this as an option. It's a bit tricky to set up. It's a bit costly to set up, but it can be useful. Another option is if you're lucky to have GPS running on Linux. It works very well over X11. It's lightweight. This is how I work every day over a normal, modern network. It's perfectly doable. So I encourage you to give this a try. If your workstation is Windows-based and your build server is Linux-based, you can have there's a free X-free server. I really encourage you to try this. This is the solution that costs the less in terms of setup cost. Another tip, which I think is useful for anyone adopting GPS for the first time. So you know that GPS needs a project, but you don't have to have the perfect project to start using GPS. You can start by doing a very basic project that just knows where to find all the sources and knows maybe where to find the ALI files. And you don't have to use this project to build, but you can just use this project to navigate in your sources in GPS and use your own scripts to build. And that's another thing I want to talk about. Everybody, or almost all of our customers, have existing builds or build procedures or scripts like they can do to build a file or build the entire project. And my advice is simply launch these scripts from within GPS. So we've done the work to allow this to be customized completely from the GUI. You don't need to do any Python scripting for this one. I'm going to walk you through it. You go to the Preferences dialog in the Build Targets option here. And you take, so these are the things that GPS is capable of doing out of the box. You can clone one by pressing this button up there. For instance, you want to define your own action that will build a file. Clone the one that says compile file. Make one. And here you can, so now you have a target here that's called my target. And here what you can do is you can choose an icon, and you can choose whether it's going to be displayed in the menus or the toolbar or the contextual menu. So after you've done that, you've got the GUI elements to launch your own script as if it were our own tools. And here, of course, you have to specify the command line. One tweak on top of this is if your script can emit a string of this form, then you will get a progress bar inside the GPS for free. And if, of course, your script emits the error messages in the standard format that GCC or GPR build already do, then the locations window will be populated inside the GPS, allows you to navigate to the location of the errors. And once you have done that once, this creates a little XML file in your .gps directory, and you can share this with the rest of the team. So you can have a workflow where you provide your own build scripts through the GPS interface available to the rest of your team. I highly encourage you to do that if you have your own build scripts. Another tip. This is actually a sort of pitfall that we have a problem with this cross-references database. It's using a technology called SQLite. And this is known to be faulty or slow on drives that are over the network. So we have done this mechanism. You can specify that kind of language in the project file to tell GPS to put the navigation database somewhere else. So you can put it in a temporary directory. You can put it in a per user directory strongly advise you to not leave that database in a slow or network drive. And if you do that, that can solve a lot of the problems in navigating in GPS, or the slowness, even in indexing a project. So there you see, I'm not going to go into the details because of lack of time, but there's several options to tell GPS where to place this file. This is, of course, in the GPS documentation. I'm going to list some examples of things that are easy to do with GPS scripting. You can associate key shortcuts to any action, and then you can share these key shortcuts with the rest of the team. You can create menus and buttons for launching your own tools. So outside of pure build tools, you can have a tool that checks out something, or a tool that launches a verifier or something. You can make some files read-only to a scripting API. For instance, if you have some files that are generated or some files that are forbidden, you can make them read-only, like prevent accidental edition. Similarly, you can change the color of backgrounds. For instance, if you have some special files that need to be double-checked by Oliver before they're submitted, you can make them with a red background and share that with the team. You can display a welcome message for anyone starting on your project. You can display a help message. You can provide basic dialogue saying, please input this, or please do this action, and the dialogue that will be presented to the users. That kind of thing is very easy with GPS customization. Each of them is maybe 2 or 3 lines of Python. So it's definitely worth having a look. This is just an example of ideas of things that are useful to our customers. Some advanced things, if you're willing to invest more work, you can provide full views. Like you can have a tree displayed in the interface of GPS showing your own custom data. You can take advantage of the libedalong customization. So Arnaud talked about libedalong. It's a library for code intelligence in Ada. You can write your own scripts using that. This shipped with GPS. You can go, and some of our customers have done this, you can customize the VCS. You can provide your own menus for your own VCS, and do this only from the Python side of GPS without having to modify the code, of course. Once you have done that, a question that we get a lot is, how do we share the plugins with the rest of the team? And this is where the plugins live in GPS. So this is, in .gps, you've got your personal plugins or your personal preferences. One mechanism that we have is if you have a project named foo and you create a file foo.ide.py, this contains Python code that will get loaded by GPS and interpreted as a GPS plugin whenever you load that particular project. So you can check in your GPS script or your GPS customization alongside the project file. That can be very useful if you have some specific actions that are to be done only on one given project file. If you have some plugins that you want to share with the teams, and if you control the environment variables on the workstations of your team, you can enter a series of directories into this variable called GPS custom path. GPS will load everything that's there as plugins when starting. And finally, you can install that if you don't want to mess around with the environment of your workstations, but can control the installation of GPS itself. You can write your plugins right there in the installation of GPS. That will work as well. So the last, I think, FAQ, GPS should be fast. So for instance, on the GPS project, on my Linux virtual machine, it takes 3 seconds to launch, 12 seconds to index the entire project for navigation, and around 1 second to open large editor. So there's a reason I'm saying this, is that we've got customers reporting things to us, like saying, oh, in the past year, it's taken GPS 1 minute to display this or that. For us, 1 minute to block the UI is completely unacceptable, and if we're just not made aware of the problem, we can't solve this. In this case, it was a customer who was using CodePeer and who was having regularly 100+ editors open at the same time in GPS. And we simply never tried this combination before, and there was a quadratic loop somewhere, so we were able to fix it. So please report if GPS is slow. This is the kind of times that you should be seeing on a normal disk and a normal machine. This brings me to my last slide. The best tool for adapting GPS to your workflow should be the AdaCore customer support. So again, this is like we've seen a wide variety of workflows and setups, and we've got ideas to help people. And the more we know about your setup, the more we're able to help or point you into what could be helpful. So don't hesitate to reach out to support for this kind of question. That's it. Are there any questions?